Hi guys, we're going to be talking about circles and mainly circles on the SAT and like the equations and like how to solve these problems on the SAT 2 subject test. So what I have on the screen is a problem that you can just write down real fast. So the problem is a circle with center 4, -3 and radius 3 times √5 intersects the x and y axis at what points? Well, so to make it clear, the center of this circle is at a location of coordinate 4 and then -3, and it has radius 3 times √5, not the cube root of 5. Okay, so that's our problem. So I'm going to teach you how to work through this. I'll have to erase all this. So circles. Circles are just a shape where all the points are equal distant from a radius, r. So here we go. Okay. So the first thing I'm going to talk about is the equation for a circle. The equation for a circle is x minus h squared plus y minus k squared equals r squared. What is all these points? So the x and the y are the coordinates, of course, and then the h and the k, this is the center. These are the coordinates of the center. So this is the x coordinate of the center, and this is the y coordinate. X, y coordinate, and this is the x coordinate. What's the r? R is the radius of the circle. So that's the equation for a circle. And this is similar to a Pythagorean theorem because the x squared plus the y squared has to be equal to a distance r squared, since each point is equally distant from the radius. Okay, so we're going to try to use this equation to like solve the problem I had on the board. Sorry. So in the problem that I had on the screen, so it asks which points does this circle intersect the x-axis and the y-axis. Well, I want to make a visual setting so you can see what's happening here. So this is our circle. So we want to find this point. This point is the point at which it intersects the x-axis, and this point is the point at which the circle intersects the y-axis. But you notice that there's two possible points for each x intersection and y intersection. So this is our 2 points for y intersection. These are our 2 points for x intersection. What do you notice about all these 4 points? Well, at this location, y equals 0. And also at this location, here, y equals 0. But what about here? What about here? At this point, x is 0. And at this point as well, x equals 0 as well. So mainly to summarize is that at each point of intersection at which the circle intersects the x-axis, the y will be 0. And at the point that the circle intersects the y-axis, the x-axis, x will be 0. So that's how we find the points of intersection. Well, using that visual reference, so let's use our equation. So we know the standard form of a circle, which I'll just write down again. Actually, I won't because that's going to take too long. So, so then the problem, it tells us that the coordinate of the circle is 4, -3, and it tells us that the radius that the radius RAD is equal to 3 times the square root of 5. So applying all this to our equation, so we can plug all these values in. So we get that x minus 4, because 4 is the coordinate of the center of the circle, squared plus y plus 3 squared equals 9, which is 3 squared times 5 equals 45. So I'm gonna resume this video so I'm gonna break it down in 2 parts, and I'll finish the second video soon. So let me summarize it up. The equation for a circle is it's x squared plus y squared equals r squared. But if it's not centered at the origin, you have to, each coordinate will minus the point of location of the center, and you'll see that when we do our practice problem here. So thank you for watching, and I'll finish my second circles video as soon as possible. Thank you. Bye.